A steel tank used for fuel delivery is fitted with a safety valve that opens if the internal pressure exceeds 1000 torr. It is filled with methane at a temperature of 23 degrees Celsius, which we know is our initial temperature, or T1, and a pressure of 0.991 atmospheres, which similarly is our initial pressure, or P1. If the tank is placed in boiling water with a temperature of 100 C, so here we are assuming that the tank will heat up to the temperature of the water, meaning this is our final temperature, or T2, will the valve open? So what's this question asking? All it's really asking for is if P2 is, or the pressure after heating, is greater than 1000 torr. Because we know if the pressure is greater, the valve is going to open and it will release some of the pressure. But if P2 is less than 1000 torr, the safety valve won't need to open, so it'll stay sealed. As always, we can solve these problems by writing down what we know for our initial conditions and our final conditions. And we know that our initial temperature, T1, is 23 degrees C, which we can convert to Kelvin to give us 296 K for our final initial temperature. And our final temperature, T2, we know is 100 degrees Celsius, or 373 K. We also know that our initial pressure, or P1, is 0.991 atmospheres. But that doesn't really help us much right now because we know the valve is going to open if the pressure exceeds 1000 torr. So we need to convert our pressure in atmospheres to a pressure in torr, which we can do because we know 1 atmosphere equals 760 torr, gives us 753 torr for an initial pressure. And of course, P2, or our final pressure, is what we're solving for and trying to find. But what about volume and amount? They aren't specified in the question. Well, if you think about it, if we draw a small tank here, applying heat to the tank will increase the temperature. And we know from Charles's law that it'll also increase the volume. But it doesn't change the size or the volume of the tank itself. So we know that V1 equals V2 because the volume doesn't change, and because it's sealed, the amounts stay the same. So N1 equals N2. And if we put this into an ideal gas expression, P1 V1 equals N1 R T1, where we're keeping in mind that R is a constant. And P2 V2 equals N2 R T2, again, where R is a constant. We can solve for R. R equals P1 V1 over N1 T1, and R equals P2 V2 over N2 T2. And because we know that R is just our ideal gas constant, or our universal gas constant, and it's the same in both cases. So we can equate these two directly to give us P1 V1 over N1 T1 equals P2 V2 over N2 T2. And we know from up here that our volume doesn't change. So these are going to cancel out. It doesn't matter that we don't know the exact volume or the exact amount. It's the same on both sides. So we can cancel those out to give us P1 over T1 equals P2 over T2. And solving for P2, we get P2 equals T2 times P1 over T1, which equals 373 K times 753 torr over 296 K, which, calculating that number exactly, gives us a final pressure of 949 torr for our final pressure. And now going back up to the question is asking us, will the safety valve open? Well, we know that 949 is less than 1,000 torr. Therefore, the valve will not open.